So this type of problem has shown up on some of the old ACTs. So if you guys are planning on taking an ACT, it's possible you'll see something like this. So I want to make sure that you understand how to set it up. There's two different ways that you can approach these problems. I'll show you both of them. They're just two ways to think of the same thing. All right, so these are those types of problems where it says if you work at one rate and somebody else works at another rate, how long does it take you combined to get something done? And so here's the sample problem. Okay, if you take 3 hours to mow a lawn and your sister does it in 2 hours, how long would it take both of you together to mow 5 lawns? Okay, you can set it up either of these two ways, and I'll show you. I think the second way is probably easier, but we'll see. Whatever works best for you, you should use. All right, the first one is to set up a rate for each person. So if you look at your rate, for you, again, this is that unit analysis. We look at, here you do 3 hours to mow one lawn. So one lawn per every 3 hours. That's your rate. Okay, your sister's rate is one lawn per every 2 hours. Okay, now again, you can tell it's a rate because you're talking in terms of one lawn per hour. All right, so once you set up these rates, what you can then do is identify how much time it takes to complete this task. So the way that you look at that is the total work, okay, which we know here the total work is going to be 5 lawns in this particular case. So we take the total work, 5 lawns, is equal to the rate times time of each individual. So here's your rate times some unknown value t, plus your sister's rate times that same amount of time t, because you're working together the same amount of time. And so here's the equation that you would wind up with. 1 over 3 times t plus 1 over 2 times t equals 5. Okay, so if you solve the equation in this way, either by hand or using your calculator, I'm going to do it by hand simply because I'm not going to project the calculator out to you guys. So if I wanted to solve this equation by hand, what would I have to multiply every term by in order to get rid of all the fractions involved in this entire equation? 6, right? So 3 and a 2 and a 1, so that's a 6. So if we distribute 6 to each of these terms, we get 1/3 of 6 is 2, so we get 2t, plus 1/2 of 6 is 3, which is 3t. 5 times 6 is 30. So we get a total of 5t equals 30, divide by 5, and we get t is equal to 6. So it's going to take you 6 hours to mow 5 lawns if you work together. All right, the method that I would probably recommend or prefer would be this other one, which is just use the idea that the total rate is equal to the rate of the individual people. Okay, so if you take your rate, so again, 1 lawn per 3 hours, and we add that to your sister's rate, which is 1 lawn per 2 hours, that's going to give us the total rate. So the total rate, it was 5 lawns in how many hours? Unknown, right? So that's where our variable goes, t hours. So this is the equation that you would get if you're setting it up this way, which is what I'd recommend. So 1/3 plus 1/2 equals 5 over t. Okay, that equation right here can be solved in the same manner. What would we have to multiply both sides or all parts of the equation by to get rid of the variables? Now it's not just 6, but 6t, distributing that through 3 goes into 6, leaving a 2t. 1/2 of 6t is 3t, and then here the t's cancel. 5 times 6 is 30, and you see it winds up being this exact same equation here. So you'll solve it in the same way and get t equals 6. Okay, so that's setting up and solving for those work problems. All right. Questions on that? Yeah.
Why you choose 6?
Why did I choose 6? Oh, so anytime you're looking for LCDs, least common denominators, so we know we need a factor of that. We need an LCD that has a factor of 3, 2, and t. and the smallest factor that has all three of those is 6t.